Hello everyone, today we are here to run AI models on our Ubuntu machine in Linux. We have RTX 5070, 12 GB of VRAM. So we are trying to test models here. Preferably Gemma will test and encoder instruct models basically. So Llama, it's very good for beginners. Llama.cpp needs some intermediate stuff. Second, it's more easy to use llama, but llama is there for more control. So you want to get more control in the sense that, let's say, the context sizes that runs by default in llama is around 4096 or maybe 2048. So in llama we can, for every run we can specify the context sizes, and I have ran up to more than 12k context sizes, so it's fine. Grainy control is here. For the same model, llama uses more VRAM, but llama.cpp uses less VRAM. Then there's a different format of storage also. And for llama, it's easy because all the models are there in the repository. You have to download it. But in llama.cpp, we will be using Hugging Face to download the models and then use it. So that's something in a nutshell. If you want to have the comparison of why will be using llama.cpp here, we'll go from start. I'll just switch on to my other scene. What would you do first? Would you install NVIDIA drivers, right? CUDA drivers. So let's do that. So we need to have some build essentials in order to do the build stuff. So we need the build essential dkms, linux headers, curl, wget, etc. So I would be just installing those because it's kind of a fresh Ubuntu machine here that I'm using, so that everything is black and white. Obviously I'll put on all the lines of code in my blog that will be linked in this video as well. So now that being said and done, now we'll go forward. Driver devices, so you can see this. I have 5070. These are the devices available. Without thinking much, I would directly go for installing the recommended one. It's up to you to choose any one of these which is very well suited for your hardware. For mine, I will go with the recommended one. Secure boot installed in your system. You may have this message, so you'll have to use a password for a secure boot. It's over. Now I'll have to reboot. Let me reboot the system and join in again. I've rebooted the system, so now let us check NVIDIA drivers. I'll go ahead and NVIDIA SMI in order to check it. So you can see on the screen the drivers are installed. I have 12 gigs of VRAM, out of which 2 GB is being used. So yeah, that's done. Now we'll have to go and install, let me clear this, install the CUDA toolkit. So I'll just install sudo apt. We need not install whole CUDA on toolkit, and because my preferred version, latest version right now that can run here is 13.1, so we'll install that particular version. It will definitely take some time. It could not locate the package. Okay, let me rewrite this again. But in order to write that, I'll have to add the package repositories. So just go to ChatGPT or somewhere else or Google. You could use wget and add those repository keyring. So I'll be adding the CUDA keyring here in order to enable the download. So you can see it's added. Now you'll have to install the keyring once it is added. So sudo dpkgi install that. and then you'll have to, you know, update the keyring that you have added. Can be upgraded, so I'll also upgrade the packages. Install CUDA toolkit 13.1 again. Okay, sorry, it's 13-1, not dot. My bad. So I'll just put it in path. Let me put it in path first, and then I'll reload it. Nano bash rc. Forgot to put it in path. Just go scroll down to the bottom of this file, of bash file, and then at the bottom you put both these paths, and you can have a comment also like for CUDA, and here you can paste the paths. This is the path, that is Control O, Control X. Now you can write source bash to reload it. And now let me check. It should be running. It was running. Yeah, I've got 12 gigs of VRAM and it's done. Let's clear this stuff and let's move ahead now. Now I can check the NVCC, you know, version, NVIDIA version. So yes, I can see the version here. It's release 13.1, which is required for us. So now we'll go again to build the dependencies. I'll copy paste this again in order to have build essentials, cmake, git, and curl. And these are the build dependencies that we need in order to build llama.cpp. Let me make a directory of AI, mkdir AI. I've made a directory of AI. Now let me go to clone, git clone llama. You can get the GitHub repository for llama.cpp. It's under ggml org. Cloning llama. That being said and done, we can now go inside llama.cpp directory. So here I need to make the build now, so I'll copy this cmake command here. Now this is the place where you may get the build errors because of the patching not yet done for the headers. Yes, we're getting this error. Just for this you'll need to update the header files here. So do one thing, you can follow my blog, or you could directly copy all of these here as such and, you know, paste it in ChatGPT or somewhere, some AI model, so that it will give you exact position where you need to go and edit the headers. Okay, and that is an RQS. Let me paste it in ChatGPT. I'll show you this particular file also. Let me bring it in screen. Yeah. So here you could see, yes, this is exact incompatibility issue I expected. Even I know about that. So this is the best fix. They are saying GCC 14. So yes, I'll have to install that. So just copy and install this make of. Go and remove this build and try to make this again using this, targeting this particular GCC make. So we'll do that. Move the build from our folder here because we are inside our folder, and we can paste build command again. We are getting error again. It's because of the error files again, which I think it still fails. Yeah, this one. This is the error patch fix that you need to do right now. Okay, just open this. Once you are here, you'll have to find this particular position. So just copy till here. Okay, and press Ctrl W here. Search window will here and paste this RQST double, so yeah, you get this position. So this device function declaration is the position when you need to change stuff, so you don't have to change it, you basically have to add no exception true at the end of that line. Okay, so just go in here, put some space here, you'll have this done. So I've added it in the end. You press Ctrl O, it will be overwritten, but it's not done yet. You have to find another place where there's a float written this position, this position, and there also you'll have to add the exception stuff. So just go again, add, use Ctrl W, paste your search term float in. So here, so at the end you'll have to add this no exception to be true right now. So I'll go to the end here, I'll paste no exception to be true. Good. I'll overwrite. I have not closed the braces here, so I'll do that again. Done. Let me run that command of building again. Good. So now it's done. So this header editing is required right now for Ubuntu 26 LTS, which is latest, and for 50 series RTX graphics card, which is also latest. These are not patched yet. This will be patched in future. So if you're watching this video around 1 year down the lane when it's uploaded, then I think it would already be patched, so you will not get this error. You may not get this error, but since we got this error, we fixed it. We'll go ahead and I will copy the build command, which is this one, cmake build llama.cpp is built. Fine. Now I will go to Hugging Face and I'll download a model right now. Let's do that. Let's get out of this directory right now and make a models directory here, because right now we'll go about downloading models and then running it, because our llama.cpp installation is complete after CUDA installation. Now I'll just go and install. Maybe I do have Python 3 by default, right? Yeah, it's there by default. So I'll just install venv, which is generally not there by default, right? Sudo apt install Python 3 venv. Okay, let's do that. Also pip is required. Pipx would be required also for Hugging Face. So let's go with pipx. It's just installed pipx, so I'm installing pipx in this machine. So using pipx we will install Hugging Face, right? CLI. You need not install Hugging Face CLI, you could directly download the models also, but let's go with the CLI installation. So once it is done, you will have to ensure path of pipx. Yes, it's there, so you have ensured. Now you'll have to reload this. I'll just copy paste rather than typing so much. Yeah, source bash rc, right? Now you have to use pipx install Hugging Face hub. Now HF is there. Now I'll try to download the model. So the first model I can try to download is maybe Gemma E4B E4B. Since I have 12 gigs of VRAM, I could also try installing Qwen 2.5 coder 14 billion. This is Hugging Face Gemma 4 from LM Studio community. I'll try this. This is 8 GB, the 8-bit quantization Q8. So we'll try that. It's around 8 GB. I have 12 GB of VRAM, so 8 GB would be free of that. So this should run fine. So HF, using HF, let me write use ChatGPT here, so that you get the HX code. Yeah, this one. So if you do this, and I have given my model directory here, so it's getting fine. So just copy this Okay, and then just remove this from here. Let's go with this. Download this Gemma 4 E4B into local directory in my models folder. This would really take some time, but that depends on your internet speed. The downloading speed can be increased by logging into the HF Hugging Face. So HF auth login is the code that you can use. Have to copy the token in your terminal. You can generate the token in your Hugging Face account, and then in that case there will be no rate limits applied to your downloads when you're downloading in the terminal, right? The download is completed. Here you can see Gemma 4 E4B. It was showing 8 GB, but it's 5.34 GB. Here it's showing 5.34 GB. I think you might not be able to see that. You can see this here. Yeah, so it's okay. Let us just run it and check. I'm gonna show you some other stuff. I'll just clear this. Okay, I'll paste it here. I can run llama build binary. I have this here model. NGL is maximum offloading for the graphics card, and this is the context. So for now, let's say lower context. This is something you can do it very easily in llama.cpp, but in llama you'll get the default context of 4096 mostly. So if you okay, we're getting an error because of flash attention, so remove that. Let me just check that again. I'll just go ahead from here, remove this flash attention, not required right now. So the model is loading very quickly. Now let me just open another terminal here so that I can monitor the usage of graphics card here. So I'll watch NVIDIA SMI in for 1 second. So you can see it's loaded, around 5.8 GB is used. So now I'll ask a question. Hi, how are you? Let's say this. So you get a response very early, so I'm not able to measure the utilization. It's very fast. Let me write a Python program of bubble sort. This will take some time. You can see 168 watt usage, 5.9 is the maximum memory it's taking, and I am getting the answer of bubble sort as well. So you can see 176 watt TDP, 5.9 gigs is the maximum utilization, and I have already got my answer, and so this is the answer in place. So great. Now let's test this in the localhost mode as well. Sorry, not by, what was the command? I think exit. Yeah, exiting. By is for llama. So let me run this. It's nothing but same command with host and port already written here, so that we can run it from localhost from a browser, right? So it's running here. I'll just open a browser here. Okay, this. So here we go. We have this chat system here. So here also I can type hi, how are you, and this is a better UI UX. As you can see that this is very fast, 36 tokens, 0.3 seconds, 117 TS, and this is storing the history as well here. How are you? That's good. I'll say new chat, and here I'll again ask to write the same, write Python program of bubble sort. Let me write the spelling wrong also. It's detecting that, right? So you can see the utilization also here. It's utilizing the same. Okay, and here you're getting your response also, and the response is good enough and it's fast enough. Here you can copy paste the code from here of bubble sort. That's cool, right? So this is how you can run both using terminal, and you can run this using localhost in your browser also. in llama.cpp, and it stores your history also. That this is really cool. Here you have the option to change the context sizes also. Let me increase the context size from 8K to 16K and then check the response. So let's just go in here, close this. Okay, okay, this was the command, so I'll just go from here to here, from 819 to 16384. So I have increased the context to 16K. So now the utilization should be higher, so it's higher, 6.3. earlier it was around 5.9K, right? So now I'll try to initiate another chat. Let me check this now. Yeah, now this is 16K, the updated one. So I'll run this again, running bubble sort program now, and you see this is using 6.4 GB of VRAM, 172 watt TDP, and this is also giving a reply pretty fast, so that's cool. Now you can similarly use another models. Here I have opened, this is the Gemma for E4B. I used it here in llama also, but it is faster here, I must say. Also llama uses llama.cpp under the hood, so we are basically using llama.cpp only in llama also, but here we are using directly when we are using llama.cpp. Also I forgot to mention that if you want to have vision files, image files, then you can do that also, because this here you can see there's an option of image, but it's not available. It says image processing requires a vision model. So this model E4B has vision also. You can run vision using this. Let's say this is the vision projector download. You can run this and get the vision support also. So that would be something like just pasting it here and running it, so that this is 992 MB and that vision files would be downloaded. Okay, now since this is downloaded, I could again run this, and let's refresh my localhost. Okay, it's not there. What? Sorry, I'll have to change my command. It's not the same command to run. You could always go to ChatGPT also. So this is the way you run vision CLI, but we want to run vision CLI vision in localhost, right? So it's the same, whatever it's in CLI, you'll just have to add that particular projector, that is vision projector, and it should run fine. So let's just run this and then refresh your UI. Now you could see there's images and audio files. These are already enabled now, so you could click on that, browse the image and upload, and then resume with your sharing system, and it will work fine, since there is a vision support in this particular model. The vision model will take a little bit more space. It's 8.5 GB that it's utilizing. You could again write hello, and then check the usage. It's 8.5 maximum. It's very good for running in a 12 GB VRAM. I hope this tutorial was beneficial. Do let me know. Thank you very much for watching the video, and please share the video if you like it, and subscribe to the channel also if you want to support me going further and making this kind of videos. Thank you everybody. See you in the next time. Till then, bye bye, take care and peace.